Blindly adding AI to the systems doesn't make them intelligent. It just makes failures harder to explain. AI is everywhere today. It's predicting traffic before you even start driving through Google Maps. It's deciding what you'll watch next on Netflix and YouTube. It's improving your photos with portrait mode and night mode on your phone. It's silently filtering your inbox, separating spam from important emails. And for developers like us, it's completing our code before we even finish typing. But here's a real question: do we actually understand how AI works? And more importantly, where it should and where it should not be used? Hi, I'm Manish Malik from Simplify AI, and in this video, I'll simplify AI without the hype, no buzzwords, just clarity. So, who's this channel for? If you're a backend developer, a QA engineer, a full stack developer, a tech lead, or you're trying to understand AI beyond demos and tools, this channel is for you. My goal is simple: to help you understand AI so you can actually build reliable systems with it. So, just starting with the major and the most important question in 2026, and not only 2026, even before that, when we started talking about the artificial intelligence, what exactly AI is. So, let's start with something important. AI is not a magic, AI is not intelligence like humans, AI is not replacing software engineering. At its core, AI is just systems that learn from pattern and make probabilistic predictions. Traditional software follow rules. If this happens, do that. If this is the rule, do that. AI systems are different. They learn from pattern, from examples. Instead of hard-coded rules, they follow whatever they have learned from their previous experience, from the patterns, from the data that we are providing to the models. See, large language models like ChatGPT are just one type of AI. Very powerful, but not the whole picture. Okay, let me explain when I say AI systems are different and they learn from pattern. So for that, let me explain the difference between traditional versus AI system. So let's start with the traditional software first. Traditional software, how it works: humans write the explicit rules, system executes exactly what is coded, and behavior is predictable. See example: if temperature is greater than 30 degrees centigrade, then turn the AC on. System will follow whatever I've written. It will always follow it. The key traits are logic first. It is always deterministic. It can break. It can surely break if the rules are incomplete or I've done the wrong pattern. So these problems can occur. So traditional system does not learn. It just obeys what I am writing, the rule. AI systems, they are pattern based. They learn, they adapt, and then they take decisions. See how AI works. Let's take ChatGPT as an example. What it's really doing is learning patterns from data. Humans give it massive amount of examples, text, conversations, documents, code. The AI breaks this data down, creates internal representations, and store those patterns so it can use them again. And the important part is this: see, no one programs the exact rules. The patterns emerge automatically from the data. Now compare this with the traditional system. In traditional software, we would write a rule like, if the subject contains free and the sender is unknown, then mark the email as spam. That works, but only for the cases we explicitly handle. So an AI system works very differently. Instead of rules, it will show 1 million spam emails, 1 million real emails. And from those examples, it learns patterns such as word combinations, sender behavior, timing patterns, writing style. Over time, when a new email arrives, the AI doesn't check a rule. It recognizes the pattern, and that's why it can keep improving. It learns from experience and it keeps adapting. So it can suggest me as a human. It can work hand in hand with me, help me identifying those patterns and moving forward accordingly. Now, the question is where AI fits best. See, as an engineer, the real question is not what AI can do, it's where it actually makes sense to use AI. So, AI is most effective in areas where writing exact deterministic rules becomes hard or you can say impractical. If the logic is clear and predictable, traditional software is usually the better choice. But when the problem involves ambiguity, scaling, or constantly changing inputs, AI becomes valuable there. So that's why we see AI working best in areas like search and recommendation systems, where user intents keep on changing, document understanding, where formats and languages vary widely. Documents is one of the best examples. Customer support automation, where questions aren't always structured. Your consumer can ask different kind of questions. Code assistance, where patterns matter more than strict rules. So this is majorly for the developers. In all these cases, AI doesn't replace software engineering. It is actually complementing it. Traditional systems provide structure and control, while AI adds flexibility and intelligence where rules fall short. Okay, so AI is most valuable. Just to summarize, it is most valuable where rules break down, not where software already works well. We have already covered where should we use AI, but where AI should not be used. So this is extremely important topic. AI should not be used everywhere. First and foremost rule. As powerful as AI is, there are areas where using it unnecessary but actually risky. So you should not rely on AI systems that must be exact, predictable, auditable. So let me give some examples here. Authentication and identity verification, authorization systems, access control, financial calculations, my billing logic. So it is a financial institution, all the calculations, billing logics, core business values, where actually you are writing the policies, rules, compliance, and regulatory checks. So these are something it has to be streamlined every time. It has to be exact answer every time. It has to be deterministic, predictable every time. It should be auditable. All of these examples are cannot vary according to different rules or different experience. Okay, the reason is simple. AI systems are probabilistic by nature. They generate the most likely answer, not a guaranteed one. See, critical systems, on the other hand, must be deterministic. The above systems, which I just talked about, the same input must always produce the same output. A login should never be probably succeed. I talked about authentication and identity verification, right? Financial calculation cannot be almost correct. I just talked about that as well. Well designed systems should use AI carefully and deliberately. See, it's majorly to assist human or enhance the decisions, but they never place AI in control of critical parts. Understand it carefully. So, just to summarize at the end, using AI wisely isn't about using it everywhere. It's about knowing exactly where not to use it. So I have just talked about the most important topic, AI, where you should use it, where you should not use it, traditional systems, AI systems. And in this channel, I'll focus on practical AI engineering topics like RAG, retrieval augmented generation, vector databases, AI agents, workflows, backend integration with AI, cost, security, reliability, and real production lessons. So everything will be explained from an engineering mindset. See, AI will be part of every software system going forward. The real advantage will come from understanding where to use it and where not to. If you found this video useful, consider subscribing. I'll be sharing simple, practical AI content regularly. Thanks for watching. Thanks again.